This problem is an application of the first law of thermodynamics, and it says over several cycles, a refrigerator does 15,000 joules of work on the refrigerant. The refrigerant in turn removes 75,000 joules by heat from the air inside the refrigerator. It asks how much energy is transferred by heat from the refrigerator's inner compartment to the outside air. What is the net change in internal energy of the refrigerant? What is the amount of work done on the air inside the refrigerator? And lastly, what is the net change in the internal energy of the air inside the refrigerator? So what we've got to be careful about is first what system that it is that we're talking about, and we want to watch out for things that are positive, negative, and zero. We'll first start by drawing a diagram. Here's the inner compartments of our refrigerator. Now, a refrigerant is usually going to be Freon for a refrigerator. So instead of saying refrigerant all the time, which could be a mouthful, I'm just going to say Freon. And then we have the outside compartment, or the outside of the refrigerator. And so we have 75,000 joules, it says. So I'll draw this in here in my diagram. It says it removes 75,000 joules by heat from the air inside. So the inside has 75,000 joules go into the Freon. And then the Freon has some kind of energy, some amount of energy transferred to the outside. What we want to figure out is we want to figure out how much heat is transferred to the outside. So what is our QC? So for letter A, our system is the Freon. So we always want to be wary of what it is our system is. So we have heat added to the Freon. We want to know how much heat is removed from the Freon. We go to our first law of thermodynamics. Q is equal to W plus delta U. And so we need to know what our values are. When we look here, we see that it first says over several cycles. So it is a cyclic process for the Freon. And so therefore, for letter A, we know that delta U is 0 joules because it says it is a cyclic process. Next thing, it says that the refrigerator does 15,000 joules of work on the Freon, on the refrigerant. So therefore, the work is negative because it says it is on the Freon. So we got to watch out for those key words like on or by. And finally here, we have that the heat is transferred from the inside compartment into the Freon. So the heat, the 75,000 joules, is entering the Freon. So that is our QH for the Freon. However, this here heat, Q, is the total added minus removed. So our equation here, again, Q is added minus removed. So we have 75,000 joules is added minus the amount removed is equal to the work, which is negative 15,000 joules, plus the change in internal energy, which is 0. And so we get the amount of heat that is removed comes out to be 90,000 joules. So that's our answer for part A, 90,000 joules. Now for part B it is, what is the net change in internal energy of the refrigerant, of the Freon? And we've actually answered that question in part A as well. So we've actually said, here's our answer for part B, the change in internal energy of the Freon is 0 joules because it is a cyclic process. So we've actually answered letter B before we got to our answer of letter A. Letter C asks, what is the amount of work done on the air inside the refrigerator? So for part C, we're actually asked to find for a different system. Instead of the Freon, we have the air. So let's erase this here because it's all applied to Freon. So for part C, our system is now air inside the refrigerator. And so we see that the refrigerator is a rigid container. It's not going to change in volume. So since it's a rigid container, that means it is isovolumetric or isochoric, as it is often called. And therefore, the work is 0 joules. There is no work because of that circumstance, because of being a rigid container. The refrigerator air doesn't expand or get compressed itself. For letter D, it asks, what is the net change in internal energy of the air inside the refrigerator? So again, we're talking about the air. So we go to our first law of thermodynamics. We see that from part C, the work is 0, so the heat is simply equal to the change in internal energy. Now the heat, there is no heat being added. No heat is being added, only 75,000 joules is removed. So the heat is negative in this case, and it's negative 75,000 joules is equal to the change in internal energy. So the problems in this case are not difficult mathematically, but you got to be wary of all these key words like on, cycles, added or removed, and a diagram often helps for you to determine what system it is that we're talking about. And although heat might be added to one system, like the Freon, so 75,000 joules was added to the Freon, so it was positive for that system. The 75,000 joules was removed from the air inside, so for a new system, it was actually negative. So you just got to be careful about if it's added or removed to or from our system that we're referring to at that time.